Okay, Zach, this is lesson number 71 that starts on page 288. We're going to go over trinomials with common factors and subscripted variables. This is easier than it sounds, so don't let all those fancy words discourage you because this is going to be a great lesson today. All right, first let's look at this little comic. Looks like these guys are fishing out there and they look back and this is what's going on in civilization. And this guy's saying, I'll tell you what this means, Norm. No size restrictions and screw the limit. Right? That's what... I think he is thinking a little short term when they might have bigger fish to fry, right? But okay, here we go. Now, the first thing we're going to go over is trinomials with common factors. And the first step in factoring, so you remember a couple lessons ago, they have been giving us problems with factoring, right? So something like x squared plus 6x minus 3, something like that, right? And then you have to factor it. But sometimes the equations are going to look a little bit more complicated than that. And the first thing you should ask yourself in step one is there a common factor that I can just pull out from the beginning and make it a little easier for me, right? So that's going to make it easier for you. And this guy, Michael Scott, I think that pretty much sums it up. He's saying world's best boss. I don't know if you remember from the show, but he actually bought that for himself. I'm thinking of getting myself one, world's greatest teacher, world's best teacher, something like that, but I don't know. Alrighty, here we go. Example 71.1. This is the best way to explain it is to just jump right into an example. And the example is this. And if they wanted us to factor this, right, it would be a little bit confusing because here we have an x cubed. So this is not exactly a quadratic equation. Remember, quadratic means the highest power we have is a 2 because that makes a square. A square has 4 sides, therefore a quadratic equation. So, but I also noticed that there's an x in an extra x, it looks like, in each of the monomials compared to what we've been doing before. So what they want us to do is figure out if there's a common factor, and there is here. So the first thing we're going to do is pull out an x. And then inside the parentheses, you're going to have x squared plus 6x, now just 1x plus 5. And now if you only look inside the parentheses, this is something that you're used to factoring. Okay, so for now, I'm going to sort of remove this x in the parentheses. I'm not going to forget about it because it's still there, but I'm just going to like take the rest of this equation and factor it the way I'm used to factoring. And now we can figure it out. So I need two numbers that are going to multiply together to get 5 and add together to get 6. And this is a pretty straightforward one. So, whoops, I don't want to do that. I wanted to do this and this. So the two numbers are going to be 5 and 1, and there's nothing but positives in this. So I'm going to keep everything positive. They multiply to make 5. They add together to make 6. And then I'm going to not forget about this x that I took out. And that comes out and goes out front. And then you have 3 things that you end up like sort of multiplying together to make this initial equation. Okay? But now it's factored out. Now things can be factored out. So that's it. That's all there is. That's all there is to this lesson. That's what they want us to do and figure out. So let's do another example. Don't be like this, right? I don't want to work. I just want to bang on this mug all day. You've probably had days like that where all you want to do is something silly, maybe like watching YouTube or just like twiddling your thumbs or something. Let's do example 71.2. So here's the equation that they give us. They want us to factor this. But the first thing I'm going to do is pull out anything that I can. Anything that is a common factor. So I see that there is a 4 and an 80, which can be divided by 4. So I'm going to pull out a 4. Then I see that there's a b in everything. So let's get that b out of there. And then I see that there's an extra x because there's x cubed, there's an x squared here and an x. So then I'm going to pull out an x. And what am I left with? I've got an x squared for that first part. I've got a minus x, right? Because I already took out the 4 and the b and one of the x's. So just a minus x. And then that last one is a minus 20, and that's it, just minus 20, because I took out the b already, I took out the x, I took out a 4. Okay, so that's what this sort of simplifies to. X squared minus x minus 20 times 4bx. So now I just have to factor this portion of it, just like we have been, okay? X squared minus x minus 20. So I need two numbers that multiply to 20 and add to a negative 1. And it's got to multiply to a negative 20. I can't forget about that negative. So what if we do a negative 5 and 4? Or it could be 5 and negative 4. Or it could be 20 and 1. But there's no way I can get those to add up to a negative 1. So I'm just going to get rid of those factors. It could be a 10 and 2, right? Like a negative 10 or a 10 and a negative 2. But there's no way I can add those up to make a negative 1. So I'm just going to get rid of those. So the things that I can add together to make a negative 1 are just this one, right? Because 5 minus 4 is a positive 1, so I can't have that. So the right answer is this one. Okay, so let's factor that. So I have a negative 5 and a positive 4. So this is going to be x minus 5, x plus 4. And then don't forget about the stuff you factored out before. So that is the answer to that problem. Let's do 71.3. Okay, so look at this equation, and right away I see that there is a negative 1 right there. And when I see that, I'm like, nope, don't like that. I don't like that. We want that coefficient to just be a 1, just a positive 1. That's it. So if I see this right here, I'm going to factor that out first. So I'm going to pull out a negative 1. Then that basically just like changes the sign of everything, doesn't it? Because if I multiply this times this, I end up getting this, right? So that's how I factor it out. And then I change the sign of everything else, because if you multiply it by the negative 1, it's going to be back to this. So that's how you factor out a negative 1. So there you go. And now I can look at this part of the equation and just factor that. So I need two numbers that are going to multiply to get negative 20, and they're going to add to get a negative 1. So let's look at my 5s and 4s again. What if I have a negative 5 and a positive 4? If I multiply it, I do get negative 20, and if I add it, I do get that negative 1. Yes, so that's going to be it. That's the winner, winner, chicken dinner. A negative 5, and a positive 4. Now I could FOIL this out and make sure that I got the right answer. But there you go. And the other point to make is they don't write it in the book exactly like this. They just have a negative sign out front, which is the same as having a negative 1 out front. So whatever, it's the same thing. Okay, so you can check your answer. Basically, here they take it one more step further, because they say when you've got a negative 1 out here, you could have multiplied the negative 1 by either binomial. So you could make it look like this. You could do negative x plus 5 and then x plus 4. Or you could keep the first one the way it is and change the signs on the second one. Why does that make sense? Because think about it in simpler terms. What if I have a negative 4x? That's the same as having this, negative 1 times 4 times x. It's the same as having a negative 4 times x, or you could have a 4 times a negative x. It doesn't matter. But if there's a negative out front like this, like a negative 1, you can multiply one of these by that negative by changing the sign of one of them. But you don't want to do it to both because that would be having like a double negative out front. So you could also multiply this times the x and then you get this one. So when you have this negative out front, you can change the sign on these or you can change the sign on these, and that answer would be equivalent. But I think this is the best way to write it, just the way it is like this. That makes the most sense to me. All right, let's look at example 71.4. They want us to factor this. So the first step is to see if there's anything I can pull out. I know, we're about to get hurt again with another example. That's okay, we're ready for it. So I'm just scanning across. I see a 3, and I see that these are all multiples of 3, because when I add 7 plus 2, that makes 9. 9 can be divided by 3, so therefore I know 3 goes into 72 evenly. And I see like an extra x that I can pull out and the negative sign that I can pull out. So let's pull all of that out. A negative, a 3, and an x. And what am I left with on the inside? I'm going to have x squared because this times this makes this. And then I'm going to change the sign and do positive 2 and another x, because now this times this makes this. And now I'm going to change the sign. What's 72 divided by 3? Apparently it is 24. And now this times this is going to be that. So I can pull all of that out. That's fair. And now I have to just set this aside in my mind and just factor this part of the equation. So if we factor that part of the equation, I'm trying to think of two numbers that if I multiply them, make a negative 24. And if I add them, they make a positive 2. So what can you multiply to make a negative 24? So one of them's got to be negative. So how about 6 and 4? 6 times 4 makes 24. One of them's got to be negative, so it's got to be the 4 that's negative because the 2 is positive. So it's going to be positive 6 and negative 4. And then don't forget about that 3x that we already factored out. And that's the answer. Okay. All right, let's do 71b, which goes over subscripted variables. This is way easier than it sounds. A subscript, remember, is when you've got a word or a letter, and then the sub is way down here, like a little lower, smaller letter that goes with it that indicates something about that. Okay, so a subscripted variable. For example, a lot of times in word problems, and that's one of the keys, these are going to be word problems. I know we all hate them. Okay, the n is used for an unknown number, even though we have a lot of x's and y's in the variables. Sometimes when we do story problems, we use an n for something that we're trying to figure out, some unknown number. Okay, so for example, let's do a quick review of variables like x and y. So they might give us two equations like this. 5x plus 10y is 125. X plus y is equal to 16. And there are two ways we can solve for x and y. We can use substitution, where we notice that, let's see, x is equal to 16 minus y, based on this equation, right? And so we take this and we plug it in for the x. And by doing that, we only have an equation with y's in it. Then we can solve for y. Then we can plug that in to this one and solve for x. Okay, we've done that before, easy peasy. The other way to find the x and y is the elimination method. Elimination. So this is where we poop something out, right? So we add them, we eliminate things by adding these two equations together, this one plus this one, right? When we add them together, sometimes we can get one of them to cancel out, okay? And then we poop that out and then we solve it, right? So we know how to do that. We've done that. Now, this is interesting because look at the X and Y's here and you can see what they're about to be getting at, all right? So what if X represents the number of nickels and Y represents the number of quarters? And they want to know the value of it. You do 5 times the number of nickels, 25 times the number of quarters, and you're going to get maybe like $2.90 or something like that. So this is a clue to what we're going to be setting up for in the future. Same thing with this up here. What if, just hypothetically, say you have 16 coins and you have a bunch of nickels and a bunch of dimes. And the number of dimes plus the number, or the number of nickels plus the number of dimes is 16. But also the value is $1.25. So if you have 5 times the number of nickels, 10 times the number of dimes, the value is this. So you have 2 true things, and then they're going to ask, can you find out the number of nickels and the number of dimes? And that's why it makes sense sometimes to change this to the number of nickels and change this Y to the number of dimes. It's the same thing. You're not changing anything about how you do the equation. You're just changing the letters so that you know what you're solving for. And when you get Y, when you get the answer for Y, you know, oh, I just figured out the number of dimes. And when you get this NN, you can figure out, oh, I just figured out the number of nickels. And so that's what they're setting you up to do in the future, okay? So let's look at example, so here, when you see some word problems, these are some of the things it could be. NN is the number of nickels, ND is the number of dimes, NQ is the number of quarters. You don't have to remember that. That's just a variable. It can change. They can change it. They could say, you know, G is the number of nickels. Who knows? Like, why does it have to? Anyway, you get it. But let's do example 71.5, and we're going to use elimination method. That's why I put this. Just pooping it out. You know how I be. We're just going to poop out one of the variables, okay? We're going to figure it out. It says use elimination to solve this. So these are 2 sets of equations. They're both true. And I kind of feel like what they're saying is, you've got a certain number of nickels, you've got a certain number of dimes, the total number of coins is 16. And if you add up their value is going to be $1.25. How many nickels, how many dimes do you have? If these are both true, then that's the kind of problem that we're going to do. Like, I have a feeling in the next couple lessons, it's going to be a word problem like that. And instead of them giving you these equations, you're going to have to figure out these equations. But let's take it one step at a time and let's just figure out how to solve these equations. And it's easy peasy. Just pretend they're X's and Y's and just do it the regular old way. Okay, so here, what I'm going to do is I'm going to get rid of that. I'm going to multiply everything on the bottom by -5. Why? Because that way I'm going to get some things to be eliminated because I'm using the elimination method. If I multiply everything by -5, then I've got -5 times the number of nickels plus, let me give myself a little more room here, -5 times the number of dimes equals 16 times -5. What is 16 times -5? Turns out it's -80. So I'm just going to write that there. And I can get rid of that plus sign because it's basically just a minus at this point. Now I'm going to add these 2 equations together, like this one on top plus this one on the bottom. And when I do that, I see that this 5NN minus 5NN, that cancels out. So that just goes to nothing. Now I'm going to add the next column. 10 times the number of dimes minus 5 times the number of dimes. So 10 minus 5 is just 5 times the number of dimes is equal to What's 125 minus 80? Turns out it's 45. So 5 times what equals 45? ND is going to be equal to 9. So now that I have that ND, I can plug this into any of these, whichever one is easier, and get n times n with subscript n. N. All right, so let's do that. So I have ND. I'm just going to erase this because I don't need it anymore. So if this is true, and I plug this in for here, then the equation I'm going to get is 5nn plus 10 times 9 equals 125. Does that make sense? I just plugged this into here. Now let's just solve it. 5nn plus 90 equals 125. Subtract 90 from both sides. That cancels out. 5nn equals 125 minus 90, which is going to be what is that? Oh, heck, I can't even think right now. I'm going to get out my calculator. This is so lame. I can't believe I'm doing this, but 125 minus 90 is 35. Duh. Number of nickels, 7. Okay. Easy peasy. I just realized it would have been way easier to plug it into this equation probably, or maybe the other one. Yeah, that's okay though. You get the same answer either way. Okay, let's do example 71.6 and do it. Do it now. You know why? This is the last example and then we're going to be done with this lesson. They want us to use substitution this time to solve. And substitution is a good one to choose because this equation is already solved for NQ. So I can just plug this into here for NQ and start solving, right? So let's do that. I'm going to rewrite this equation, except when I get to NQ, I'm going to plug in this. All right, so let's do it. 5nn plus 25, now I'm going to plug that in, times nn plus 2 equals 290. Okay, now I've got to multiply that out. 5nn plus 25nn plus 50 equals 290. See how I did that? I multiplied this by each one, by this and then by that. Okay, so 5nn plus 25nn, I can add those together and get 30nn. Then I'm going to subtract 50 from both sides, equals 240. nn equals 240 divided by 30, because that cancels out. What's 24 divided by 3? It's 8. Okay, so nn is equal to 8, but now I also need to find nq. So I go back to my equations. If this is 8 right there, nq is 8 plus 2, and you get 10. So nn is 8, nq is 10. Easy peasy. That's the whole thing. The end. All right, just a little comic for you at the end. Here you go. Looks like aliens are landing, right? Wonderful, just wonderful. So much for instilling them with a sense of awe. This guy really screwed things up because he fell down the stairs, right? And all these people are like, what the? This guy. Anyway, that's pretty funny. All right, have a great day, Zach. Have fun doing your math. Bye.